All right, we're live. February 24th. Take a look at what today's LeetCode challenge offers us. It's kind of late today again. Man, I was bogged down on some app development, but it's all good. It's all good. Or let's take a look. Score of parentheses. Oh, score of parentheses. Interesting. Looks to me a simple question. A balanced parentheses. Okay, so it's balanced, which means it's valid. Compute the score of the string based on the following rule. Open and close, score 1. A, B has score where A and B are balanced parentheses strings. This score is 2 times A where A is a balanced. So, okay, so this is basically like a concatenation of 2, and we score 1, and this will be scored 2. So it has a very natural recursive relationship. So I'm looking for recursion or not. You know what? I don't think it is recursion. So it's balanced. So I mean, usually it works on stack, and recursion is stack as well. It's only 50, so it's definitely recursion. We can actually go, so when we find a left, we push into the stack. We recurse, and another one we recurse, and then the first time that we find a right, that will score 1, and we come out of we come to the previous level, and we return the value, and the value will be doubled. And okay, so for this sense, where we see the left, we go recursion, and then in recursion, which goes to the next one, we see a right. Do we immediately go recursion? We see a left, and we check the next, and the next is right with no recursion. That's just at this level we return 1. Yeah, so we're gonna return. So we see a left, right? We're gonna return the total score that is captured by this left and the corresponding right. That's what we want. So we have a left, right? And then we go to the next one. If the next one is left, we recursion it. If the next one's right, we can return 1 because that's the total is 1. So for this left, okay, we look for the next one. The next one's the left, so we recurse into this. And then this will return 1, and then we look for the next one. And the next one will be a right. So that ends, and then we 2. This one will be left, and we cut 1, and then we have to plus. Yes, we have to plus, which means as we're going through, what we're doing is we check every single one. We check a left, a recursion, and when it's done, we find a right when it's done, and we move on to the next one. So does that also mean we have to keep track on the index? I mean, we do have to keep track on the index. How do we keep track on the index? So we need to have a index that's when it's done. So we currently have this, right? It's gonna be like a while loop. When we have an index, we index at the start, and we know it's a left, and then we increment, and the next one is still a left. Then we push this also, so we have the starting, and then we have to return the score, and we return the score and the ending. I think we we kind of have a general idea, not 100%, but I think we can take a look just to play around with some ideas. Might not 100% work, but I think we have the gist. It's going to be recursion, that's for sure. Which I think will be easiest to use recursion. So we're going to do a def, I'll just say compute. So what we need is an index, right? An index, which is the front, and also, well, that's it. We just need an index, and we're gonna return a tuple. The tuple will be an int and int. So we're gonna do here. There's gonna be a tuple for the dot. So the tuple will be index and score, right? So we're gonna check if the current is left, then we is that how we do it? Hold on. What we want is we have the front, right? And then compute this must be a left index, and must be a left. So what we need to say is just index plus 1, right? And then we say if s index plus 1, because s index must be a left parentheses. So if this is a right parentheses, then we're gonna just return index will be, next one will be index plus 2, and also if index is equals len s, I'm gonna return 0 index, and else I'm gonna return index plus 2 because that's the next one, and it's going to be 1 as a result. Else, which means it's a left parentheses, then we are going to do we're going to compute index plus 1, right? That's the next one. When it's done, we're going to have a index, new index, so we have index and score is equal to this. So this is the next index and the score, right? So the index, now we're going to check if the index is, yeah, so we're going to check if the index, so we probably need to, we'll have to put in that, like while index is smaller than len s, right? While this, and if this, if not, the index and score. So we need to have a total score. It's 0, right? And then we're coming in, index and score. So this is like not, right? So we're gonna say total score plus equal to score. Hold on. It's not total, it's inner score. Yeah, it's not total score. It's inner score, and then we go back up to check the next one, right? So after we done the recursion, right, and we go back up, we want to check if the next one is a right parentheses. If it is the right, oh, then it's not plus 1. because when we return, what type of index do we return? We go in, we always go in with the left parentheses, and we go out, we always go out with the right parentheses. Yes, let's do that. We go out always on a right parentheses. And so here we compute, that's a parentheses inside the original parentheses. And we compute when we get the index. That's the new index, which is the right parentheses of the inner pair. And we get that score as well. Then we increment the inner score, and we come back up. That's the index, which is the right parentheses of the inner pair. And it's smaller than it's smaller than, it has to be smaller than len s minus 1, because we have to do index plus 1. So we always think that the current is a left parentheses, or so the current is not going to be the ending of a right parentheses. Yes, so in this we do plus 1 and we check. If it is good, then the score we return is not 1, but it's going to be, so this is 2, right? Oh, this is, okay. It's going to be depending on the inner score, right? So if we have inner score, then it has to be 2 times inner score. If inner score. If not, we're going to return 1. And then we have this for inner score. And then once we are done, will we come out here? We don't come out here. Actually, because it is definitely going to be the case that we have a valid, so we can actually do this here. So we say while is not this, right? And then we do all that, and then we're going to return index plus 1. Okay, now we just need to do just return compute 0. That's our start. Okay, let's take a look, see if our logic stands. We have a regular, this gives a 1. We have a double, give us a 2. And we have a concatenate, let's give us a 2. And finally, we have a super duper complex one, which I must copy and paste, which gives us 6. It's going to be uppercase, and this is score of parentheses. All right, moment of truth. Take a look. Out of range. So it does go out of range. Okay, so we're going to do index smaller than len s minus 1, and it's not correct. Plus returning different values. All right, it's fine. That's fine. It happens, and we are going to look at it. Okay, let's see. So what are we gonna return? So first of all, I think this is an issue, and we're gonna return. It's gonna be just a score, so it can be like this. But it's not. It's still not gonna be correct. Yeah. I think. Okay, hold on. I feel like there are a lot of issues going on here. Hmm. All right, let's just take a look at the first one. How come this one's also not correct? So we compute 0, right, at a 0 position. So 0 comes in. 0 comes in, and then index is 0, 0 smaller than Linus is 2. 2 minus 1 is 1, 0. Yeah, that's good. And while this and this, no, that is not correct. I think something is very wrong. While this and this is not equal to right parentheses, undo this. When it is equal, okay, so the first one pass. I feel like the second one will pass. The third one not gonna pass. Yeah, the third one is not going to pass because the top level I am only doing one time. So because this one I'm only considering one parenthesis. So when we're done, so we have to consider a res equals 0, and we are going to be we have an I as well. It's all 0, and then we say while I is smaller than len s, and we return, going to be returning that. So when we return the right parentheses, so it's not going to be exceeding, so it has to be if while this is smaller minus 1, and score, so in I score equals compute I, and the rest plus equals score, and we keep going, and then we're going to return the result. That is to handle the case where we have parallel. Yeah, it's not right. All right, what is the problem with this? Why would it be 3? So the first one coming in, right, 0. And that's good. It's equal, so we come out. I'm going to return index plus 1, which means 1. We return 1. And we return 1. So score gets 1. Rest gets 1. And the next round, I is 1, so compute is 1 coming in. So 1 is good. And we're going to do... Oh, that's not... Oh my god, we are... Hold on, this is... So, are you saying that when... It's because we are working on... Yeah, that doesn't feel right. So when it's in parallel, we kind of have problem with parallel right now. Because... Okay, hold on. And we push, and then we get 1. We pop, that's 1. And all right, so let me change my mind. Feel like, so what if we just do a stack? You know, it's simple, easy. We push left, and then we push right. When we pop, we're gonna pop both, and then we replace that with a 1. And then at the end, we're just gonna sum it up. All right, so we have push left, and we have a right. I'm looking at this case right now, and we have a right, and we pop it out, we replace with a 1, and then we get a right again, because we guarantee that whatever is in it is going to be a single number. So we see the number, and we going to pop the number, and we're going to have a temporary. We're just going to pop this, pop all the numbers until we reach the left, and then there's going to be a sum, and then 1 times 2. Okay, so left pop will be 1, left pop. That also going to be 1, and then we return the sum of this. Now we solve all 3 cases. This is the last case we need to solve. So I'm going to push left, left, right, turn into a 1, and then we're going to push left again. That's fine. And left, right, turn to a 1, and then right, and then we're going to convert everything inside. So this is going to be a 2, and then finally a right. So we're going to put these 2 together, be 3. Yes, yes. Okay, so we wasted 20 minutes trying to figure out a unsuccessful recursion, while in fact this one can be solved just by creating a stack. So what we're going to do is going to be for letter in S. If letter is a left parentheses, we just going to be stack dot push, not push, append the letter. If letter is a, that's else, because there's only 2 possibilities. Now when it is a right parentheses, we need to check. We're going to say temp equals 0, and then we're gonna do while stack and stack top dot is alpha, is num, is numeral, is numeric. We're gonna say temp plus equals stack dot pop until it's not. Until it's not, then what we're gonna do is we're gonna do stack dot pop. That one is pop the left parentheses, and stack dot append. We're gonna append the temp, the score of the current parentheses, and that is it. We're going to return sum of stack. Okay, let's take a look at this one. See if this one works. Int object has no attribute, is numeric. Oh. Easier, just because the only thing we pushed in is the left parentheses and the value. So just, if it's not this, rest is 0. Ah, what the heck. It's not as easy as I expected. Left parentheses append. Go to the next one is a right, temp is 0. Stack if it's not, and oh, so if it is, oh, hold on. So if there is any, and so if temp is, so append temp times 2 if temp, else 1. Okay. Yeah, we forgot that. There we go. That is the solution. We are going to pass this. Confidence. Super duper confident. Yep. There we go. So it took us 24 minutes. We could have gone this direction, and to begin with, we We did a little bit detour, but at the end, it's all good. It's all good. I mean, I'm trying to see if we can save a few lines. I don't really think so. We can save a few lines. Oh, so instead of pop, we can just say -1 equals replace with score, right? Because, yeah, still pass. Anything else that we can conjure? Yeah, I think this is about it. Yeah, this is about it. All right, so again, as usual, let me just say, as usual, parentheses related questions, problems can be solved with stack. I originally wanted to use some fancy recursion, but I got bogged down in some non-trivial, it's actually the index position issues. I backed out of that solution and went for the stack one. For the stack. It turns out the stack solution is much better. Is much better. Both cleaner and faster. The ideal is simple. When we see a left parentheses, we always push it in the stack. When we see a right parentheses, we pop the stack if there are scores already in it. We pop until we encounter the first left parentheses. Now, this is a pair. We accumulate the sum of all the scores contained within this pair, within the pair. If the score is 0, which means there is no other parentheses inside the pair, we change the top of the stack to 1, which is the score of the current pair. Otherwise, we double the score contained within the pair and also change the top of the stack with the score. When we finish the whole string, our stack shall contain only the scores. We return the sum of these scores. ON, no problem, and we hit 24 milliseconds with 95% ranking. Pretty good. All right, let's check. I feel like there might be a solution on this. Yeah, I think it's an easy question. It's medium. All right. Divide and conquer. Oh, this can be done with divide and conquer. On squared stack on. Oh, look at this. Look at this. Left stacked append 0. Okay. Else, which means it's that, we're gonna pop, stacked up, pop the top, and wait, what are we pushing in? Oh, hold on. So we pop the top, which contains the current score. I think that's what it means. Will contain the current score. Current score. We append 0 if it's left, or append 0, 0, 0. And if it's right, we're gonna pop the 0, and we're gonna use that stack space to do the accumulation. Okay, so in a push, and we have this, we have a right parentheses. We're going to change the score to 1. And if we keep having left, and then we have a right parentheses, and we're going to pop it. And then, so if we have, all right, so apparently, if we have a nested, we're going to be 0, 0, right? Let's just consider a situation of left, left, right, right, right? So it's going to be 0, 0, and the first right coming in, the 0 will be popped, which means the left parentheses will be popped, and we can be accumulating based on the first non-nested parentheses. And then the next coming in, we are going to pop again, and we're going to accumulate still on the top the current value. So we're accumulating everything. What if like the left, right, left, right? So left to right, append 0, we pop this, we change the front value. And then we append 0 again, and then we pop the 0 and we add it into the front. Ooh, man, this is and we're not gonna do divide and conquer. Let's just go here. Every position in the string has a depth. Some number of matching parentheses around it. The dot has depth too, because of these parentheses. Yes. Goal is to maintain the score at the current depth we are on. When we see an opening bracket, we increase our depth, and our score at the new depth is 0. When we see a closing bracket, we add twice the score of the previous deeper part, except when counting this, which has 0, has a score of 1. Okay, so we have 0, 0 after parsing both. No, we have initial 0, current frame, and first one, second one, and then we have this. Now at this level, which means just the previous, I'm going to pop it, turn into 1. Now I'm going to new, 2, and then we have this level, 1, and we encounter this again. So when we encounter this again, so this we know is the deeper score. So we pop this one out, times 2, and add to the front, because this because this is the deeper, and the front one is always the one that match the current with 3, and then we have one more, so we pop this one out. Ooh, wait, this is good. Oh, we got one more. All right, a third solution apparently is very amazing. We're gonna take a look at third, but this one's good. I mean, it's the same solution, but it's more elegant, right? It's more elegant, which means that we have a left and a right parentheses. Every time it's going to be a left, we append 0, which means that is the current score corresponding to the left. So all the left are going to be 0. And when right comes in, you're going to look for the current top. So that current top is the left parentheses that matches the right parentheses. And all we need to do is to keep the score on the top, right? If it's 0, that means there's nothing in it. Then if it's not 0, that means we have a score in it, which is a very good solution. I want to implement it. And it's going to be solution 1. We can have a solution 2. So this is from the official solution. Okay, so we're gonna have a stack. So the stack, I think the trick is we have to put 0 here, because when we pop it, yeah, we have to put 0 because we have a pop. When we push 1 0 and we put a right parentheses, and we don't need to pop it, all right? We just change it in place, and then we don't need this. So we can just say for letter in S, if letter is a left parentheses, we do stack dot append 0 as current score. Else, then we do stack -1 equals, right? There's no pop because we have to pop. All right, do we pop or do we not pop? If it's 0 0 and then we enter 1, right? And we have to pop. Yeah, we have to pop because the pop, that is the score inside, right? That's the score inside. We need the popped value to determine. So yeah, we have to have a 0. Unfortunately, it is true. So we're gonna say score is stack.pop, right? And we're gonna say plus equal. So this is the current level score. It's going to be 2 times score, if score, else 1. And we're gonna return stack -1. Solution 2, all pass. Yeah, this is a very good solution. Very good solution. The key intuition is that instead of pushing left parentheses, we push 0, which indicates the current score associated with the parentheses pair. Whenever a right parentheses appears, we pop the top of the stack. The value is going to be the score that is contained within the current parentheses pair, except when the score is 0, which means the current pair does not have any score within it. Then we update the current top of the stack, which represents only like, unless it's like this, which represents the score of the current pair. Yeah. So this is going to be a good solution. Yeah, and this is important. This initial 0 is important. It is the score of top level. It is the top level score. Top level score. If you have nested, it can always find its way back to the top level. But if you have top level, you need something more at the beginning. So this will run in O(n) as well. We're just going to just take a look. Run the code, see if anything is fine. Yeah, and then we submit it. That should be good. Yep. All right, let's take a look at the last one. Count the cores. The final sum will be a sum of powers of 2, as every core will have its score multiplied by 2 for each exterior set of parentheses that contains that core. So we just need to count the number of cores. Keep track of the balance of the string. For every right parenthesis immediately follows a left. The answer is 1. As balance is the number of stereo set of parentheses that contains this core. What the hell is balance? Okay, so if x is left parentheses, balance plus 1. Okay. If x is right parentheses, balance minus 1. Okay. And if s, so the current I is, which means, so this gives us a parenthesis pair with nothing inside, right? Then answer plus equal 1. Move left by balance, that's just times 2. Okay, which means if the balance currently is 0, then answer increment by 1. If the left is not, so if I find a right parentheses and I look to the left, to one left, it's not, then I don't do this. Don't do this until, hold on, I don't understand. I do not understand. Okay, so Ix is this, right? So I'm just thinking about a simple case. I mean, this case we done, right? I got it. How about this case? We have a left, balance is 1. We have another left, balance currently is 2. And now we have a right, balance is 1. So I have 1 that has balance. And if it's left parentheses, that's true, then answer plus equal, because we balance 1. Okay, so I think it's different idea. So we do the answer only when we encounter the parentheses that is in the center. That's in the center. So here we only compute the answer when we are at this level, at the center. And we use balance, which is the number of layers that is outside the center core. That's the core. Yeah, outside the center core. That's true. Oh, I think I know. Because when you have a balanced parentheses string, right, they're going to be cores, like the center of the onion, right? There are only so many center of onions. And the solution will be to find all these centers, right? And the value of the center is always going to be 1. But you have a lot of layers on the outside, so you just keep count how many layers are outside the onion. So when you find the center of the onion, the total score will be 1 multiplied by by 2 many times, depending on how many layers we have. And a very efficient way to do that is to do a left shift. Left shift the number of layers that's outside the core. And we just do addition. Oh, wow. Great solution. How much cores would there without having? Yeah, I like my onions analogy. Definitely, we're gonna implement this. There's no question about this. This is great solution. This is another one from the official solution. It is called, what is it called? Count cores. Count cores. While yet I am going to refer to it as the onion solution. For any valid parentheses string, there we can see them. We can see it as a bunch of onions. Each onion might have 1 or more layers. And the intuition is that there are only is that we can always locate the center of all the onions. And once we find the center, which is a parenthesis pair without anything else contained within, we know that we will know the score of the whole onion as long as we know how many layers are outside the core. So the problem becomes to keep counting the number of layers. Keep counting the number of layers until we reach the core. And once the core is reached, the total score is incremented by 1 left shift number of layers. Then we move on to the next onion. Very brilliant solution. All right, so let's implement it without looking at the solution. So we're going to put it here so we cannot see it, and we implement it ourselves. So it's going to be the onion solution. So we need a result, has to be 0, and we want also a layers, so it'll be 0, right? So we're going to have for I a letter in enumerate S. We're going to say if letter is a left parentheses, right? If it's a left parentheses, that means our layer just increment. Else, the right parentheses, our layers decrement. And after decrement, we need to check if si minus 1 is equal to the left parentheses. If it is, we have found the core. Then we can increment the answer. Answer will be 1 left shift in the number of layers. And as we keep going on, we're gonna, if they're like a very thick onion, after we find the core, the remaining will be a lot of right parentheses, and the layers just keep decrementing until we go to 0, and then we move on to the next onion. And that is it. We're going to return res. We'll try solution 3, and it's going to be passing everything, which is wonderful. This is a wonderful solution. That's fine. Let's just leave it. Submit. 28. Good solution. Good solution. Very good. All right. We went through all 3 solutions. This one is eye-opener. This one definitely is eye-opener. Very, very good. Discussion. Anything more? O1 space is this solution is O1 space. Approach 0 is stack. Array. I do it in array. O1. Oh yeah. Oh yeah. One good stack problem. He has one liner. Mr. Lee 215. Eval. Eval. I think what it's doing is it's replacing this with this, and we're replacing this with 1, and replace a right with, oh my goodness. Oh my goodness. Yeah, what's the time complexity of this? Yeah, it's, I don't think so. But, oh yeah, that's true. That's true. This is plus, yes. And this is 1, yes. And the remaining will be this, yes. And we evaluate it. Holy guacamole. Yeah, it's good. I like this guy as well. Yeah, same idea. All right, that's it. That's it for today. We 3 solutions. Our solution is pretty similar to this, but it's apparently this one is more elegant. And this is just some black magic, you know. But once you figure it out, you can see the beauty of this one. Yeah, the beauty. All right, that'll be it for today. We will keep working and keep fighting for tomorrow when it counts. All right, see you guys. Adios.